I've got um, I've got material. I've got videos. I've got all sorts of things that I'm going to share with you. Uh, and I will share it at the end. So I'm gonna go back and forth between my presentation deck, which for me is more about keeping me on track. Okay, so but I'm going to go back and forth from that into other things. I want to know, does anyone not know how to get back to the Google Meet if I take you someplace else? If anyone has an issue with that, please let me know now and I will try to walk through that process. We all good? My And when I get to videos, I'm going to have to represent to make it so, you know, what happens with the audio. And I'm so sorry. But okay, are we good here? I'm actually just. I'm going to present. Okay, so the objectives for today and what we'll have for the week is to distill the theoretical information down to essential and practical. And I say essential and practical because we can never do everything that research tells us we should do. So we want to get down to bare bones. What do we absolutely have to do? And we want to be able to have strategies that will help us. Well, obviously not today, but starting next week when we get back in class, things that can help us right now without having to learn crazy new things. So we want to make it as practical as possible. And I would love to see a framework of continuity for us and our students. And what I've noticed here at within schools is that there are teachers, you know, in one grade level that know one thing and do things one way, and then another teacher has like, oh, I've gone to do really great reading, so I'm using that, and another teacher says, well, I took OG from Ron 15 years ago, so I'm using some of that, but some of these other things and some of this other stuff, and terminology does not then cross the grades, and more than terminology, just the whole emphasis doesn't cross the grades. So if we can move towards having more people be able to support with the same focus and understanding, that helps the kids. So that's one of my objectives. And I know that's not a short-term objective that we can handle this week, but that's my longer term, what I would love to see. So outline, and just bear with me. I'm going to go over it quickly just so you know what's in store. We're going to cover theoretical more today and cover the practical over the course of the week. An overview of how the brain learns to read based on current neuroscience and backed by evidence. You know, there's always such this schism of, okay, researchers say this, educators say this, and they don't talk to each other. And researchers don't know that what they're suggesting educators can't do. And educators don't always know what the researchers have been coming up with. And so with this age of information transfer, it's becoming better. But we want to close that gap as much as possible because researchers don't always know what teachers have to go through, and teachers, we don't get to know what the researchers are doing. So the more we can combine it, the better for our kids. Okay, so we will look at an overview of basic and advanced phonics and spelling generalizations. We will look at the background information to make sense of English orthography. Orthography, ortho means straight, graph means to write. So ortho, like an orthodontist, your teeth are straight. So it is the rules. So English spelling rules. We're going to try to make some sense of that over the course of this time. And the background of it. So we'll go into background. Current research on the best practices for spelling and sight word learning. Because we have some great advances in this field backed by research. Current research on the remediation of phonemic manipulation skills and why it's important. Now, we've known since 2000 and the National Reading Council, their report, that phonological awareness was one of the 5 pillars. We've known that, and we've not known enough. So the research in this field is what has really skyrocketed reading instruction the most. And so we're going to concentrate on this quite a bit. And yes, even for older kids. So younger kids, we know they need phonemic awareness. And the old research said that phonemic awareness skills could really end by the end of 1st grade. In fact, I was trying to find a practice quiz of, so we can test ourselves on our knowledge. And I found quizzes still in use today that say that phonemic awareness instruction can end at the end of 1st grade. I'm like, no, we know that that's not true. Stop. But there are still quizzes that are being used by professional development organizations and reading, pre-service reading instruction in schools. So, anyway, so we will try to look at the more current research. We're going to look at the role of morphology in reading instruction, and this will be primarily for the older grades as we go on to Thursday and Friday, for those of you who are coming in for the older grades practical application. And also for the older grades, we'll look at step-by-step procedures to decode multisyllabic words, and it's not as intuitive as just saying sound it out. We've told kids sound it out, and it doesn't work because they can't make their way through that whole long word. So we will go through that. That's the outline, and then I will also provide reference material and cheat sheets and things that I have found useful in the classroom. Okay. So why is this important? And we know that Hawaii is not even as good as national average, right? So percent of U.S. 4th graders below basic level in reading, basic level, not proficient, but basic level, we're still at around 35%, not even meeting basic level. And research shows again and again that if the students have attained it by 3rd grade, remediating it beyond 3rd grade is super, super, super difficult. So we want to lay the foundation as best we can in the early grades, remediate as best we can, as efficiently as we can in the older grades. But we all know it's a problem, and we want to help fix that problem. So let's see what we can do. Okay. So the research can tell us what to teach. That's what research does. It gives us content. And it can tell us why we need to do things. We have to let the why drive the how. And this is my big deal, because I'm going to just stop this for a second so I can look at you. When we, as educators, when we learn something, we go and we present it to our class, and we get so bogged down into there's so much to cover, so much to do. I can't possibly cover everything I need to cover. And things start falling by the wayside, right? It happens. It has to happen because there's just way too much to teach. I mean, for instance, when I took reading from Romualda Spalding back in the 80s, she was reading instruction takes 3 hours a day. 3 hours a day. You're going to fail if you can't do 3 hours a day. Well, who can teach reading instruction for 3 hours a day? Nobody. So of course things would fall to the side. So we have to let the why we do things drive how we do it, because that gives us our priorities. And if we don't know the why we do it, we won't understand the priority. When we teach math, do we ever sit there and say, you are going to do this, you're going to do this, and then you make a mark here and you do this here, and you write the squiggle down here? And I have seen kids that knew that if they saw a squiggle that looked like what we call a number 4, and if they saw a squiggle that looked like a number 3, they were going to write a squiggle that looked like a line across and an angle down, and it was just squiggles and there was no concept behind it. And I have seen those kids. But when we teach math or when we teach anything else, we try to stress concepts, right? Because it's the concepts that's going to stick in the brain, that give us the framework to hang everything else on, that gives us the framework to prioritize instruction. So why we teach is so important. And that's what's going to allow us to prioritize, because none of us we would all love 3 hours a day to help remediate our struggling kiddos, and we don't have it. So it's the why we teach that has to drive the how, right? When we just teach just the content, you know what happens, right? Kids learn the content and they might be able to retain it long enough to get through their spelling test on Friday, maybe, or they might retain it long enough to do whatever the goal was, and they've done their worksheet, they checked off their I can goal, and they move on and it's forgotten. But when we get back to the concepts of why we do what we do, we are able to prioritize and reinforce as time goes on. So it's not just another check mark. Yep, we did that. Yep, I met that goal. Yep, I covered that standard. So standards are all good. I love standards, but it's seeing the long-term concept through time that's important, and how we're going to support that. All right, get back. That's my soapbox. Sorry. And anytime anyone wants to say anything, please just unmute and speak. Okay, so why we teach the way we need to teach. One of the first things it's dependent on is how the brain learns to read. And there has been so much research in this field. It's amazing research. It's exciting research. And it validates things that we as educators knew experience worked over, since 1930s, when Orton and Gillingham put together their methods, and what we've seen in evidence of reading efficacies, reading instruction efficacies. But learning how the brain works helps us. It's amazing research. So let's talk about reading, because I hear things all the time, and you hear things all the time. You hear, well, there's so many ways to learn to read. There's no one right way. And, but what I've been doing for these years is help almost all these kids. It's just these struggling babies that it doesn't help. And we know that there have been things that have been helpful for the majority of kids for a while. But let's look at what the actual research says. So if we look at reading instruction, there's about between 4 to 7% of kids that will read with almost no instruction. If they've had a book in their hand, they've been read to it all, they're going to learn to read. Somehow their brains are wired to pick up that coding effortlessly. Isn't that lovely? We cannot build reading instruction based on those kids, because they are truly the exception, right? There's about 35%, roughly, that will learn to read no matter what kind of instruction you give them. Whether you give them whole word, balanced literacy, phonics, doesn't matter. If you give them a spattering of any reading instruction, those kids are going to learn to read. Their brains are wired that way. Okay, so that's nice. What about the other 50% of the population? Maybe even more. Okay. So then there's another 40 to 50% that need explicit instruction. Explicit instruction that's code-based so that they are taught the code of reading. And we talk about systematic and sequential. So 40% thereabouts that need that. And the degree to which they need it varies on the child. So it's a spectrum, right? So there's some kids that need just this much and other kids that need more. And then they say 10 to 15. And we're now looking at research that says it may be less than that. But 10 to 15% who are dyslexic. And the term dyslexic means not lexia words. So they can't read words. Basically, they can't read. So kids with the intelligence to read, unable to read as to what is expected of their intelligence. So that's a very broad definition of dyslexia. Although there's been work on, there being dyslexia genes, and now with the work that's being done in brain imaging, they're seeing a difference in kids who are dyslexic that way. But so the question is, most instruction, every decent reading curriculum that's out there now will meet 50% of the kids. And then depending on how explicit it gets in the instruction of phonics and phonemic awareness, they can reach up to 85. And we want to reach up to the 95 because truly they're saying now it's really about 95% of kids will be able to read if they're taught with explicit phonics instruction and have solid phonemic awareness skills. Okay, so that's 95%. So right now we're reaching about 50 and we want to get it up to the 95. So we can say, oh, well, and this is what we hear a lot is that, well, let's just give, that's what multi-tier instruction is for, is to help those who are struggling. And yes, multi-tier instruction, RTI or MTSS, should reach those. But wouldn't it be nice if we could reach that 85, 90% in our whole group instruction? And we hear, well, but doesn't that just slow down the kids who would have already been able to read well? And that was a valid concern. People said, oh, but doing that explicit phonics, all that boring stuff. And that was the impression, that it was boring stuff and it was just mundane drill, 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 drill. And I can tell you that my kids generally don't think it's all drill, drill. But that was the impression, was that a lot of what they saw as explicit phonics instruction was just boring, and it would slow down the readers who didn't need, a top 50%. Here's the exciting part, is that we see the explicit phonics instruction and phonemic awareness instruction helps even those students more. In fact, there was one just recently, Dr. Lisa Motes, I don't know if you're familiar with the name, she's one of the leaders in the field of reading instruction. She was just talking about a field where they did a study, and the already highest performing readers actually gained the most. So whereas they expected, 6 months gain in 6 months, they gained beyond that. So the already highest achieving readers gained even faster than the lowest achieving readers for whom the curriculum was originally designed. So this is so exciting to know that this is beneficial for everybody. It slows nobody down. It slows nobody down to give explicit instruction. We didn't know this 15 years ago. We assumed this, we kind of hoped this, but we didn't know it. But now we know it. We know it. So it is beneficial. So when we look at a classroom and you say, well, you know, this is the curriculum I've had and this is the curriculum I've been using, you know, all of you who have worked in the classroom, you know, I mean, Sabrina, what percent of your kids, or Carrie, what percent of your kids, or whoever's been in the classroom, David, what percent of your kids are in the struggling area, the area that you're like, they're not proficient and they need extra help? Can you just throw out a percent?
Probably about 60%, maybe.
Carrie?
Yeah, I would say mine's probably right down the middle at about 50% lack basic phonics skills.
And David, do you have a?
It'll range, but maybe 30, maybe a third of the class. Yeah.
Okay. Yeah, that's sad. Our poor Keiki. That's right. Anyone else? I can't see who else in here. So anyone else have a percent of what you've seen in your classrooms? Yeah, so the question is, when we continue status quo, are we okay with saying 35 to 50% of our kids are going to be struggling readers? Are we okay with that? And that, yes, we can, and we will make strides with improved RTI and improved MTSS instruction. But are we okay that we can have 35, 40, 50% of kids struggle? Or should we do better? So our goal is to do better for whole class, everybody. And then really reserve that one-on-one to the ones who are really truly down in that bottom 5-10%. So that would be the ultimate goal. That would be the really nice goal. And the research is saying it is possible. They're seeing 95% meeting proficiency with proper, systematic, explicit instruction in phonics and improved phonemic awareness skills and manipulation. So this is exciting. This is what we're going to hope for. Okay. So what we say is the structured literacy approach is essential for this percent here and advantageous for these. And did I put it? So we have a quote that says that it is, let me see if I get it right. It is beneficial for all, harmful for none, and absolutely essential for many. So let's do it. Okay, let's do it. So when we talk about our struggling readers, we think we know what that looks like. We hear them read, and we think we know what it looks like. And this is an area where it was really unfortunate that the Dyslexia Association was the one that did the push for improved reading instruction, because people looked at it and said, oh, well, that's only for kids who are dyslexic. And they kind of swept it by the wayside. And that's, we now know, is not true. It's not just for those people who are truly identified as dyslexic. It's for all struggling readers. So what do we think it looks like? So I'm going to send you off to a Jamboard, and I can't see. There's 10 of us in here. Okay. I'm going to share this link here in the chat. Oh, hello. I meant to just grab the link. I'm going to send this link here. Back up. I'm going to send this link, copy link address, and send it in the chat. And I want Bernie, Carrie, David, Jackie. Yes, Bernie, David, Carrie, Jackie, to go to this first link. Okay. This is what we tend to think struggling readers or dyslexic students read like. So, Bernie, if you would go to that link, read it, and then on whatever you have, or you can do it as a post-it actually in the jam, write what you think the article said. And this link, everyone else who I didn't mention, I want you to go to this link, bottom one. So that would be, I think it is Kayleen, Lori, Sabrina, Tanny. I want you to go to that link, read it, and then either write it as a sticky or on note paper, whatever, what you think the article said. This is a 3rd grade level article, and just go have fun. Tell me, write down, just takes a couple of minutes, what you think the article said. You could do it as a post-it in the sticky, or you can write it on your own paper, but then we'll get back to it. And please don't look at the other persons. So, was everyone able to get into the jam? Yes, okay. And you have your article, so just very quickly jot down what you think the article said. I'm going to give you a couple of minutes. I don't see any entries on the second one. How are you doing, Lori, Sabrina, Tanny, Kayleen? Okay, so everyone in the first group has written what they think the article's about. No one in the second group has anything on here yet. So,
oh, we added our sticky notes.
It's about the marathon, right?
shh.
Oh, sorry. I just want to make sure because what I see on your screen is different than the link I clicked on.
Yeah, the first group. So I have now moved to the second group.
Yeah, our Jamboard has a different writing.
Yes.
I think both of the links in the chat box are the same link.
Oh, really?
I think so.
Uh-oh. I am so sorry. So Kayleen, Lori, Tanny, and who was the fourth person? I want you on page 7. Did you get to page 7? I'm so sorry. I got it.
Okay. Page 7. Okay.
So if you've already looked at page 1, could you please go to page 7?
Do you want the first group to do that as well, or do you want us just to
Sure,
stay on?
go for it. Go for
Okay.
it. If you've already done the first group, but now you know what it was about. So those who have not, did everyone read the first page? I'm so sorry. I'm sorry. I ruined my experiment. Okay, so let's try look through page 7. And here's the point. We think kids who have dyslexia or any of the reading disabilities, we think that they transpose letters. We think that they try to, they take longer. But what we need to realize is they don't know which words they've misread, and that's the big issue. When kids are struggling readers, they don't know that they've misread a word. They just keep going. They don't know which words necessarily are messing them up, because to them, they're reading the words. If a child read this, how much comprehension would you get? Anyone want to speak? Do you see a difference here? What do you see as a difference? Anybody?
Yeah, that's number 7. Writing is left field.
Yes.
That's for sure. Page 1, we could totally figure it out, but this one is kind of a little more difficult.
Right. We think kids who are struggling readers, we think that they kind of skip over some words. They know the words there and they skip over it and they fill in the meaning. And some will do that depending where they are on that spectrum of disability or reading difficulties. Anyone else? What do you see here?
I would just add that the context is completely different.
So we think kids can get it by context. But when children have misread the words, they don't have the context on which to hang their hats, the rest of the meaning. And they don't know which words they've misread. That's the point, is that they don't know which words they've misread. They don't know which ones that they're messing up on. They don't realize that they're not reading punctuation. They don't realize that they have skipped over many of the words and just not even seen them. And the ability to get context goes down to about 0, right? This is what our kids deal with. This is what our kids deal with. It's not just a matter of reversing letters. It's not just a matter of they didn't read all the way to the end of the word and they dropped off the ing or the ed or the whatever the suffix is. They totally read words and they don't know which words they've misread. So when you see kids, and then depending on where they are in the spectrum, we get a lot of kids where we say, oh, he needs comprehension help. And I'm going to tell you that we rarely see kids who need comprehension help who don't also have the issue with accurate decoding. But this is what it's like. And this is what I see all the time with kids. And what happens, first grade and second grade, they're misreading. What we have taught them in our early years is that reading doesn't have to make sense. You just do it. You just say the words, and they just keep saying it. And they become used to reading not making sense. Would this make sense to any of us? Only a third grade passage, but it makes no sense to us, right? They become used to words not making sense. Well, if they're not going to make sense, why are they going to enjoy it? Why are they going to put time in it? It doesn't make sense. There's enough in life that doesn't make sense. Why put time into that? It doesn't make sense. And you see kids from 4th grade and on, they've given up because, hey, it doesn't make sense. I can't do it. And when you see a 9-year-old who believes that it's not possible to read, you know, it's like we've just given a student a death sentence, right? Like, it makes sense to everyone else, but it doesn't make sense to me. Anyway, I'm going to go back. So it is a very, very tough subject for our kids. And when you see the struggles that they go through, it's so hard. And I see kids all the time who would come in for tutoring over the years or come in and they are angry and they are sad and they are frustrated with the world and they believe that the world has told them that they're stupid. And no one has ever said those words to them. They've had good teachers, they've had good parents, but they feel like the world has told them that they're stupid and they want to give up on themselves. So it's our job to help bring them success. Okay. So the brain is this incredible, incredible thing. And it's just like, I have to read over these things every time. It's amazing. And the more research that's out there, the more they know. So they used to say that there were 2 pathways. They used to say it was unidirectional. They used to say all these things. Every time they learn something, we learn how much more complicated it is. So the brain, and I'm not going to do it justice because I can never remember all the names of the parts of the brain and the functions. Basically, reading is such a complex function. We think of reading as a visual skill because they have to look at the words. The truth is that it's a visual input. It starts out in the visual input. But reading doesn't happen with your eyes. Reading actually happens more, so it has visual input, and it happens as this part here connects with these. So this green area here is the semantic area, and they've identified more than 20 separate, I don't know what they call it, parts of the brain that interact in reading, more than 20. And every time they do more, they're finding more. But basically, there's these parts here that connect to the meaning. And this happens before a student learns to read. This orange part here connects to the pronunciation and articulation. This happens in spoken language. So a child learns to speak naturally. A child learns to attribute meaning to that sound. Like you say mama enough times, they attribute that person to mama. And we've known babies, well, they'll say mama because they want milk. Because when they said mama, you know, mama came and gave them milk, right? And then they learn to be more distinguishing on meaning, and they then learned that mama meant the person, not just the action of satisfying my hunger, and they learned milk. So all of that happens over time naturally as words, spoken words, are associated with meaning. The interesting research now is that they're seeing all of these arrows are now bidirectional, that things are happening, and they're calling it fiber bundles, that things happen in these colored arrays as they're looking at it on these fancy machines, where these things are firing and happening bidirectionally with more than 20 parts. So super complicated. This part here, and the leading researcher, and we'll listen to him in a minute, he calls it the letterbox. And I know he probably has a really fancy name for it, but he's calling it the letterbox. It is the essential link between the visual input that then talks to and relates to taking that visual input of squiggles and relates it to sounds that they hear and meanings that they know. And all of these things happen super fast and super complicated. It's amazing. It's amazing. But I want you to recognize that it is very complicated. The visual input is important, but it is input. We like to think of reading, especially those of us who learned to read in the whole word era, that it was a visual memory issue. And we now know that it is not a visual memory issue. There is visual discrimination that happens where and I'll talk about the symmetry aspect of it, but the main part that has to happen, and the main part where our struggling readers are deficient, is in this connection here, that letter to sound connection. And we're going to hear about that in just a second. Okay, so Stanislas Dane, I never say his name right. He's French. He has, you'll get this link. He's amazing. And you can see he has a video here where he shows the brain going, and he shows these bundles of things happening. It's amazing. But that one's long. So we're going to watch this one. And I'm going to try to present it and turn off my video. And if it's too glitchy, please stop me. And then if it is too glitchy, I will just send you the link and ask you to mute and watch it yourself for 5 minutes. So let's try it, okay? Anyway, he is one of the leading researchers. He's in France, and I will pause at a couple of points along the way. But he won the Brain Prize in 2014. So highly, highly, highly acclaimed researcher. And he's looking at how the brain handles higher functioning. Okay, so I'm going to change my presenting to just the tab. Let me pull it up. Okay. I'm going to present the tab, and I'm going to turn off my own camera, and I think that helps. But if it's too glitchy, let me know. Here's place. Okay. Here.
This child is learning to read. He's trying to rewire areas in his brain so it can turn shapes of letters on paper into sounds and words of spoken language. Actually, his teacher might not always be helping him because one common way of teaching probably just makes it harder to learn to read. Stanislas Dehaene knows this. He won the Brain Prize in 2014. He studies how reading takes place in the brain. He is a professor at Collège de France and the leader of INSERM CEA's Cognitive Neuroimaging Center in Saclay, south of Paris. These laboratories are called Neurospin.
In my lab, we are specializing in analyzing the functions of the human brain, and especially the higher level functions such as reading, language, mathematics, number processing, consciousness.
Watching the brain at work requires finely tuned precision scanning instruments, as well as very carefully designed experiments if you want to make sure you're actually studying a certain function of the brain. This means the scientists in Dehaene's laboratory, in order to see how the brain reads, might construct a whole hierarchy of stimuli, ranging from real words all the way down to pseudo words, or even pseudo letters that look like letters but are meaningless symbols in any alphabet.
In this way, we can isolate some of the brain processes by subtraction. We ask, what difference does it make if it's a word? What difference does it make if it's pronounceable? Where in the brain is a specific process going on?
So what actually happens in the brain when it reads? And what implications should it have for how reading should be taught? It turns out our brains build on the circuits we trained when we absorbed spoken language. In other words, to grasp the alphabet, the brain first must learn to speak. That is easy for a child. Over millions of years, evolution has hardened human brain structures for that purpose. We don't need to go to school to learn to speak. All we need is to experience a language. But evolution has never shaped the brain to read. No brain structures have been developed through evolution to make sense of letters and written words.
We were never born in order to learn to read. It's an invention. It's very recent. What we do is we recycle some of the circuits of the ventral visual cortex. Some of these circuits are specialized for faces, for instance, but we turn them into circuits for recognizing letters and bringing this information about letters to the same exact circuit that is being used for spoken language. They know about the pronunciation of the word. And especially when you're a beginner reader, the challenge of reading is to turn the letters into sound.
So that's what this child's brain is struggling with. Turning symbols on paper into sounds. Sounds that make sense because they are part of spoken language. But until he masters this conversion, he cannot focus on the meaning of the word.
Now, as you become an expert reader, you become faster and faster in doing this conversion. You begin to be able to do it for an entire set of letters all at once, in parallel. So you no longer have the feeling that you're doing this slow conversion, but it's still going on in your head.
These are findings that have implications for teaching all over the world, because many children are trained to recognize whole words when they learn to read. That might not help the
I'm just stopping here for a second because if you don't know French, he's holding the word upside down. And it looks like has read the word snos, but it's upside down. But he's been looking at whole words here.
the child at all.
Well, there is a debate in the education literature about how to teach reading. There is this idea that maybe you just need to expose children to whole words or even whole sentences, and they will absorb the reading system. We know it's not the case, and we know now that it's the other way, the explicit teaching of correspondences between graphemes and phonemes, between letters and sounds, which is the right way to teach reading, because this is the way to teach explicitly those circuits going directly from vision to spoken language. This is the preferred route for the brain. If you don't do that, if you draw attention to the whole word, there are experiments showing that you are teaching another circuit, much more in the right hemisphere, which is, you know, the opposite side of the brain.
Then you're not training the brain to read. The discovery of how the brain learns to read is an example of how scientific measurements of the brain can lead to better understanding of psychological processes like reading, mathematics, and other functions of consciousness. And it turns out, even mathematics can.
All right, I know it was a little glitchy, but were you able to understand what he was saying? Okay. I'm going to send us into the Jamboard. But in any case, back into the Jamboard, if you already have it, I can go to it. Let's go to slide 2 or frame 2. Okay, and if everyone can just put down 2 points that stood out to you so we can discuss the various things that impacted us. Oh, Ido, hi.
Hey, how are you?
Fine, thanks for joining us. I'm glad you could make it for a while.
Yeah, of course.
And he has more work on math, which is also interesting. So, but today's about reading. Okay, did everyone get a chance? So if you feel comfortable, would you unmute yourself and explain what you learned or how it might be different from what you've heard in the past, or how it might impact, or whether this is old knowledge to you? So was this old news to you? Is everyone here part of the I Teach Explicit Phonics group? Yes, great. I have been too for many years, but it was really nice learning the why that makes sense. We knew that it worked, and over the past many years, we knew that it worked, and we knew that that was the way to help our struggling students. We didn't necessarily know why. So this is just really exciting to know the why it works. And I'm going to say this, as I said it earlier, when we start with the why, it drives how we do it, and it drives our priorities. And I have seen people who have taken Ron Yoshimoto's OG class, which is excellent, and he has good material, and there are people who've done it, and I've seen this. And then they take his material and they say, I don't know where to start. And what they do is they take his word lists that are useful for teaching explicit instruction. They take his word lists and they teach them as flashcards, word by word, as flashcards. And they're saying, oh, I'm doing Ron's work. And it's like, wait. You forgot the why he has that there. So I can take any OG manual or any structured literacy curriculum or really great reading or rewards, Anita Archer's or anyone else's. And if I don't start with the why that's important, I can totally misteach the material, right? So the material itself is dependent on why it works and why we do it. Okay. We don't start with whole words or sentences. And I saw someone said, what about sight words? We're going to spend time on sight words. It was really interesting where he says that the part on the left part of the side of the brain that's now being repurposed for or connecting the letter recognition to the sound and meaning, what he calls the voice, the letterbox. He says it was repurposed from facial recognition. And this is super interesting to me because, they've done studies where they've taken illiterate groups and then taught them to read and actually see structure changing in the brain. So they can see what parts of the brain change when you take an illiterate person and teach them to read. And they see increased white matter. They see all sorts of great things happening. But think about it for a second. In an illiterate group, in a primitive culture, the ability to instantly recognize faces is super crucial, right? You got to know if that guy that's walking towards you is a friend or an enemy. That type of very quick, distinct recognition is now being reused for words, for connecting the letters, the sounds, to the meaning of the words and the pronunciation. That's where it's happening. And it's interesting because I met a man a year ago. He's 50 years old and a dyslexic man, and he never learned to read well. He was charming. He said in school he always had his girlfriends do his work for him, and they wrote his papers, blah, blah, blah. He got through. He was brilliant. He could remember every face he'd ever seen, ever. Because that part of his brain had not been repurposed for reading. That he was telling me, and I was like, oh, I know why now. I know why. That's really interesting. And he was a multimillionaire because by the time he was in college, he had already started his first company, design company, and he was designing clothing. And he had one of his college professors fail him and say, I don't know why you're doing this. You're such a failure. And he says, I've already made my first million. How about you? But anyway, he was telling me that he was having his shoes shined in New York, and he looked over and the guy in the next shoe shine, he says, oh, I saw you last year in Madras. And the guy's like, what? And he says, oh yeah, it was in Madras or wherever it was, I forget which city, and we were in the market on the same day. And the guy's like, yeah, I was there in India last year, and yeah, I did go to that market. And he says, oh yeah, I saw you. He's like, did we talk? Did we interact? Says, no, but I saw you there. And it's like, so blown away. I mean, the mind is so incredible. So I do believe we should teach all people to read, because in our culture now, that is essential. But you can see that the brain is so amazing that superpower was really important for a lot of people and in other cultures. And now reading's our superpower. We need it here. But it was just really interesting that I met this man. He's explaining this to me. I'm like, oh, I know why. I know why that is now. Because, and what Stanislas Dehaene has shown is that the part of the brain that used to be used for facial recognition has now been rewired to another part of the brain that is more of a picture area. So it's moved to the right hemisphere. So there's new circuits that does that, and maybe not as efficiently as what it used to be when it's in illiterate cultures. Anyway, so teaching doesn't start. Yes, it's essential that we turn symbols into sounds, and that I love this line, that we cannot get meaning until we have mastered that. We know the goal of reading instruction is comprehension. That's the goal. We want kids to get meaning. But that one sentence is so powerful. We cannot get comprehension until we have turned the symbols into sounds. And this is really interesting because in research they show blind people, educated blind people, read as well as a sighted person. Same level as a sighted person, because they have the benefit of the sound. So they convert the symbols to sound. So reading levels of educated blind people is exactly like educated sighted people. Reading levels of educated deaf people max out at about 3rd grade. You can get some up to maybe higher, but that is exceptional. So the average educated deaf person reads at about a 3rd grade level. And that's what we've been doing to our students when we teach towards sight recognition beyond or taking precedence over that letter, the symbol to sound correspondence. So when we teach kids with the emphasis on sight words to the visual memory, we are treating them as if they were a deaf person, not making use of that letterbox that then connects to pronunciation and meaning. So when you think of that the average educated deaf person reads at about a 3rd grade level, because that maxes out their visual memory. We don't want to do that to the kids who don't have to have that limit. Does that make sense? So let's think about Japan and kanji. Some of you, do any of you speak Japanese or know Japanese? No? Yes? So in Japan, to graduate from high school, you need to know about 2048 kanji. 2048, very specific. You know this, 2048, you can graduate high school. That's your language requirement. 2048 kanji. because they are learned primarily as pictures. And the only reason you need to know more than that is in specialized fields. They are memorizing those as pictures. When we ask our kids to rely heavily on their sight words, where it's the visual memory, we're asking them to remember, 3,000, 4,000, 5,000, 8,000 words. We're asking them at 3rd grade to already have the ability of visual memory beyond what an educated adult person in Japan needs. They don't have that visual memory. They don't have that visual memory. That makes sense? So when we see kids who have learned sight words, and they've learned every word is a sight word, and they're in 3rd grade or 4th grade, it's like, do you understand how much cognitive load we've put on that child? How much they've worked to attain that? That's incredible. Incredible. But it's not sufficient for our alphabetic language. So there is a way to introduce sight words, and we're going to spend time on how to introduce sight words that does not rely on sight visual memory. Okay, so that's going to be this whole section on orthographic mapping. All right. Okay. How does this impact our teaching? Okay, so I know most of us, and we all did it. Most of us did a lot of work on teaching whole words. And even in OG, and I was an OG teacher for many years, Orton Gillingham, we did a lot of sight words, and we did it in multisensory ways. We did blah, blah, blah. We still did a lot of sight words. And now we know better, and we will go over the process that helps take it out of just the sight word visual memory and put it back into the area that accesses that letterbox and connection to sound, symbol, to pronunciation and meaning. We know how to do that, so we'll go over that. But the point is that we can't feel bad about what we didn't know before. We just use what we do learn to improve our instruction. And because I know I felt really guilty. It's like I spent so many hours, even as an Orton Gillingham trained teacher, teaching incorrectly. And you feel bad, but it's okay. We know more, we do better, and we help the kids that we have now. I think it's I had planned on a break now, but let me just cover this one part and then we'll take a quick break. Okay, so as reading instructors, it is super difficult to teach reading because we're already good readers. We do not remember the struggle of the beginning readers. And once you're a good reader, you can't not read. It is impossible to not read. And I'm actually going to send you this link because you want to be able to hear it well. And so I'm going to send you the link, go through that link, and then take a 5-minute break. And then we'll come back it's about a 3-minute video. We'll come back at 9:25. Does that sound good? Somewhere around there. And just try to think about that. Think about the way you've been teaching and maybe where we need to go. Okay, and we'll come back at 9:25. So let me just give you